So today we're going to talk about factoring by GCF, or greatest common factor. Take a moment and label your notes, Factoring Unit 5A Homework 1 with the appropriate date, and then set up your paper for questions and comments on the right-hand side. So to factor a number or expression means to write the number or expression as a product of its factors. So we can talk about factoring numbers, and let's start with 36. 1 times 36 is 36. 2 times 18 is 36. 3 times 12 is 36. 4 times 9 is 36. And 6 times 6 is 36. Now I know I have all the factors because I reached a double factor. And you're going to notice the numbers go in order from least to greatest. And this is something I like to call a U-turn. This is how I know I have all the factors. Let's take a look at 48. Start out with 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. Now, even though I don't have a double factor this time, my next number I would choose would be 8, and I notice that it's already on the other side. So once again, least to greatest, and it has that U-turn effect. Let's look at 52. So we do 1 times 52, 2 times 26, 4 times 13, and that gives me my U-turn. 1, 2, 4, 13, 26, and 52. So these are what's known as factors. These factors, when multiplied together, give me the said number. Take a moment, pause, copy before continuing on. So let's talk about factoring a monomial from a polynomial, and this is where we're talking about GCF factoring. The first step is to determine the GCF of all the terms in the polynomial. So we want to look at what we can divide out of each term. I notice there's at least one x in each term, and all of my numbers are divisible by 2, which means 2 is a factor. So I can factor out 2x from each term. And that makes my GCF, or my greatest common factor, 2x. So next, we want to write each term as the product of the GCF and another factor. So once I divide 6x3 by 2x, I end up with 3x squared. 2x squared divided by 2x leaves me with just x. And 8x divided by 2x gives me a 4. And so I write it as 2x times each term. And then I'm going to use the distributive property to pull out the 2x from all three terms. So I would have 3x squared plus x minus 4. And this leaves 2x as my monomial times 3x squared plus x minus 4. And I can always check it by redistributing this back into the parentheses to check to make sure it gives me my original polynomial. So here's an example I'd like you to try. We have 36y minus 24. I want to look at 36 and 24, and I want to find the greatest common factor that those two numbers share. So let's start with 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. That double is going to make sure I know to cap off my U. Now let's take a look at 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. The next number I would do would be 6 times 4, which is already here in reverse. So that caps off my factors for 24, factors for 36. What I'm looking for now is the greatest common factor, or the largest number that they share. And that would be 12 on both cases. So I'm going to factor 12 from each of my terms in this binomial, which means my GCF will be 12. So 24 divided by 12 would be 2. 36 divided by 12 would be 3. The y stays unchanged. So I have 3y minus 2, with 12 being factored out of each term. Now I want to go ahead and use the distributive property to factor the 12 all the way out. That gives me 3y minus 2 times 12. Once again, I can check it by distributing the 12 back into the parentheses. Do I get 36y minus 24 back? Go ahead and take a moment, pause, copy before continuing on. So let's take a look at a second example. Here I have 15x squared plus 10x minus 5. I don't have x's in all my terms, so I won't be factoring out any x's. As I look at the numbers, I notice they're all multiples of 5. And so my greatest common factor will be 5. So 5 divided by 5 gives me a 1. 10 divided by 5 gives me 2. And 15 divided by 5 gives me 3. After dividing 5 from each of my terms, I can go ahead and distribute out the 5. So that'll leave me 3x squared plus 2x minus 1 times 5. And once again, you can check it by redistributing the 5 into the parentheses. Does it give you your original trinomial back? So here's some practice problems I'd like you to try out. 1 through 3, find the greatest common factor and factor it out. And then use GCF to solve the problem with the cylinder here. Remember, you can find the area for a cylinder, a surface area formula in your yellow chart in your binder. Go ahead and pause now, try this out. Answers are on the next slide. Once again, if you had any problem or couldn't get any of these answers, make sure you bring your questions to class. See you next class.